So let me give you the details. And we're going to basically do 3 main skills with this today. So we'll go over that. So I want to tell you what each of these things are. Guys, can we settle down and get going? Okay. M is called your maximum amount or your limit to growth. And every single one of these will have one, and I'll explain why in just a second. Okay, and then we have basically the same model presented 2 different ways. Sometimes you'll be given the equation and you'll have to just use it in the form that it's in. But do you remember from Friday when we talked about this with regard to the mathematical murder mystery that we did? Number 1 was presented as an exponential growth, like this denominator on the right side. Number 2 that we talked about was presented as what? The Newton's law of cooling. And we simplified it down, and we pretty much figured out that it always comes down to B will equal what?
E to the negative k.
E to the negative k. Very good. And that's what it always comes down to. E to the negative k is going to be your base if you're using this function here. Just that's how it simplifies and is exactly the same function either way. Okay, so I want to explain that to you. Number 1, let's do one of these together. Okay, it matches my number 9 here, so that's why I'm here. Okay, so on a college campus of 5,000 students, 1 student returns from vacation with a contagious flu. And y'all, this is on your page 1, but it's on my back page. With me? It is on your back page. You can do it either place. I don't really care. So the model for this spread of the virus is 5,000. Why do you think it's 5,000?
Because 5,000 students maximum.
Very good. You can't have more than 5,000 students sick if there are only 5,000 students. So, and then we have something down here. We don't know exactly where they got that from. In this problem,
it's by one
student, yes.
Out of 4,000.
So you have at least 1 student sick because 1 student came back from vacation sick.
What if it tells you like 3 students is so you do 3 plus 4?
We're going to do that in a few minutes. So hold on to that question because we're going to do that in just a minute. Now, so how many students are infected after 5 days?
This is just 5 for T.
I'm just going to put 5 in for T. So this is the first thing. It's really just plugging in or evaluating a function for a time of 5. And it has to be modeled in the same time period, and this is modeled in days. So it tells you this right here, after T days. So my denominator is 1 plus 4,999 e to the negative 0.8, and I'm just going to multiply by 5.
So 5,000 is like your principal?
5,000, okay. No, that's not a...
It's the maximum because you can't have over.
This is a different model. This is not starting with some amount as an A value. It's a little bit different. There's 1 student sick. The numerator is a limit. It's not your starting amount. It's actually the highest it can go. And I'll show you this graphically in just a second as well. So when you simplify that down, what do you guys get? Okay, guys, this is very calculator driven, so you've got to have your calculator out. You've got to be plugging this in, seeing what you're getting. Now, if you're going to do it all in one step, you're going to have to use parentheses for the denominator. So probably what I would do is just do the denominator and then do 5,000 divided by second answer. You know, you can recall.
Wait, you can do second answer.
You can do second answer. You want me to show you?
Yes.
Okay, so I'm going to do 1. So I have 1 plus 4,999. And I need to pull up my E, so it's going to be second ln, and then I have negative 0.8 times 5. And I could do that, but in case I can't do it in my head, I'll just show you what that looks like. Now, I still need 5,000 divided by that. So do 5,000 divided by, and then do second answer, and it will always pull up the very last thing. So you don't waste your time typing, writing something down, and then typing it in the calculator. You're wasting time.
Oh, why didn't you just do 5,000? Yeah, 5,000 divided by 1 plus 4,999.
So could I do that? So 5,000 divided by,
1 plus 4,999.
thank you, Turner. I appreciate your help.
No, because then it would, it's 5,000 divided by.
That's why I didn't do it that way.
Why? Oh.
Okay, here's what's going on. This is what I was trying to tell you. You can do it all at one time. So let me recall this again and show you a little something. If I go back over and I insert a parentheses here, not there, I went too far, didn't I? So I'm going to do second, insert, open parentheses, I'll go to the end. So, y'all, you could do it this way, and look, you get the same thing, approximately 54. Alex.
You're giving me my identity.
So, why not just do the denominator and recall it right back up? But you can do parentheses as well. I just want to make sure you don't forget those parentheses, because you're gonna be chugging along on the test. You're gonna think you got the right answer, and you're not gonna have the right answer if you don't remember those parentheses. So approximately 54 is what we got there. So that's going to be approximately 54 days. Now, part B. How many days will the college class, or how many days until the college will have to cancel classes?
So all of them are sick? Are we just assuming?
No, not all of them are sick. They tell you their policy is 40%.
Wait, how many students are infected out of 5 days, 54 days are infected?
Thank you. It's 54 students, roughly. Now, so after how many days did you have a question?
You said equal to 22,000.
Very good. Set it equal to 2,000. And I have my model, 5,000, and then I have 1 plus 4,999 e to the negative 0.8t. What am I solving for in this one?
Solving for T. Yeah, you're solving for T.
I am solving for t.
Even though you're solving for y, would you not change the bottom of it? Like, simply
What?
denominator?
Times both sides by
Hold on, she was already having a question. Aaron, what's your
Would
question?
you not change the denominator even though you're like changing up how many people?
Change it to what, though?
Like the 1.4 thousand and 299. You don't change that at all.
No, you don't. Notice the model. It works at any point on the curve. And I'll show you the curve in just a second.
So you just multiply 5,000.
I would start by multiplying both sides by the denominator.
Why?
Why?
Yeah.
Because you just divide by 2,000.
Y'all, what is our goal here?
Why don't you
Very
divide both sides
good.
by 5,000? No.
So isn't the goal to get the e to the negative 0.8t all by itself and in the numerator? So I have two goals. Okay, so I can multiply both sides and cancel this denominator out, essentially is what's happening. I'm going to show you a little shortcut in just a second. E to the negative 0.kt, and then what would negative 0.8t? What would I do next?
Divide both sides by 2,000.
Okay, I
Why
divide
don't you
both sides by 2,000. Hold on, Turner, I'm trying to show everybody. So I divide both sides by 2,000, divide both sides by 2,000. Cancel, cancel. I end up with this is equal to 5,000 over 2,000. So, could I not have just started at the very beginning? 2,000 is equal to 5,000, 1 plus 4,999 e to the negative 0.8t. Could I not have started just by exchanging these two? Yes. It's going to save you time, save you writing, and it works every single time. And a lot of y'all know that property, but some of you don't. So it's what happens with proportions. You have a fraction equal to a fraction, and that always works. You can exchange those two. So just memorize that. It's going to save you some time. I wanted to show it to you once, though, mathematically, so you kind of see it's legit. I'm not just making something up. So I'm going to end up with, let's start here. So I'm going to have 1 plus 4,999 e to the negative 0.8t is equal to 5,000 over 2,000, which is 5 halves. Now, anything you can do in your head, just do in your head. But do not touch the calculator until the very last step. Do not.
This one.
Yeah.
Is 1 plus A equal to M? Divide 5,000.
Hold on, let me finish this and I'll see what this is.
You gotta divide 5,000.
So, what am I doing next?
Divide
No, it is not divide by 5,000.
Oh no, you subtract the 1.
Order of operations
You subtract the
says this 4,999 is multiplied by e to the power.
So you just
Subtract 1,
Then you can divide by
Then you divide by 499.
and then, so this is gone, and then divide by 4,999. So that cancels. So isn't 5 halves minus 2 halves just 3 halves?
Yeah.
So I have 3 halves divided by what? And I'm not touching the calculator yet. I'm going to LN both sides, so this is gone. I know, that is kind of unfair, isn't it? So when I take the natural log, you have to remember, let me rewrite this for you. So it's e to the negative 0.8t. So it's the natural log here, and it's the natural log of all of this. And then the negative 0.8t will come down front, and it kind of messed up. So negative 0.8t, and I just divide by negative 0.8. Turner, please stop that. So time is going to be this. This is exact. And then if you have your calculator, which you will on this, you're going to plug it in.
That's not too hard.
It is not too bad, is it?
Now can you go back to my question?
So let me finish the problem, Turner. Yes, I will. So I'm going to do 3 halves, but I have to do ln. Now, if I'm going to do 3 divided by 2, I have to be careful. I'm just going to go ahead and do 1.5. And that would be divided by what? 4,999. Now, where students make mistakes, it's like they take the log of 1.5 and then divide. No, it's the log of all of that. The quotient of 1.5 divided by 4,999. I'm going to get that value and then just do negative, divide by negative 0.8. And then there's my solution, 10.139.
Wait, can you like do that all in one step, or do you have to enter and then
Okay, please stop clicking. The question is, can I do it all in one step?
Yeah, so like
I think you actually probably could do all that in one step. Okay, because when you divide, it's gonna powers. Yeah, I think that'd be fine. Just be careful not to do too much in one step.
you go to thousands whenever they don't keep you everything.
Yeah, that's a good idea. Go to the thousandth position, 3 decimal places. Now, so that's 2 different ways we're using the model. Now we need to learn to write the model. And I think that might be your question, Turner. What is your question?
1 plus A equal to M.
1 plus A equals M.
Yeah, does that work?
Does 1 plus A always equal M?
No, because look at number 10.
Not always. Sometimes it does, though, but sometimes it does
And how do we
not.
find A?
I'm going to teach you that right now. Okay, go to number 1 on your actual worksheet. So we're right here. I want you to see what this looks like graphically so you'll kind of understand. What is y equals 20 here? It's your limit. And then you also are bound on the lower side typically by what? Y equal to 0. Yeah, very good. Typically that's the case. Not always. Well, yes, that's pretty much how it works. And your y-intercept is going to be what? Your starting amount, right? What you're starting with. But it doesn't fit our normal equation where it's like a times b to the x right here. Okay, so let's do number 1, and then I'm actually going to do number 5 with you as well. Number 1, our initial value is 10. That means I have a point, 0, comma, 10. My limit to growth is 40. That's M. It also passes through a point 1, comma, 20. We talked about this a lot the other day, that it's really important to have that initial point at 0, common sum value. What I'm going to do is I'm going to use the model, and I'm going to start with my initial point. So, and then I'm going to solve for A, and then I'm going to solve for B, just like we did on the mathematical murder mystery. So my limit to growth is 40.